Hello everyone, good morning. I hope y'all doing well. It is 6:10, from where I live in Houston, and today I would like to share with you, actually prove to you some of the very important properties of derivative operator, and I think it's pretty cool. It's really cool to understand these properties from a better, a more fundamental level. And without being safer, let's dive in. So the first property I want to prove to you is, I'm gonna use induction. Okay, so on the proof technique, I'm gonna use it. Induction is really cool, guys. Like, it can do a lot. Okay, it can prove by induction. Anyway, the first property is gonna prove to you is, if you have this system, and y equals 0, then y equal to a1 a2x plus an x n minus 1 er1 x will be general solution. This is on page 2. Or other word is like, if you like linear algebra geek, you would write like this. I think you write like another way to write this is cur t minus a n equal to a0 plus ax plus an minus 1 x n minus 1 this ax a0 a1 a n minus 1 is r. Okay, yeah, so cur. So I'm gonna prove this to you. Okay, so what does it mean? It means that, let's say, okay. Actually, let me rewrite some. Did this in a summation way so that it make more sense to y'all. So y right here, I can rewrite this as, let me see. Okay. So y can rewrite like this. Okay. Okay, I can rewrite as e to power r1 x times summation I equal to, no, I'm not gonna write I because I'm afraid some people confuse, they think it's complex number. K equal to 0 to n. Okay, oh, actually no, k equal to 1 to n ak times x power k minus 1. Okay, so this is another way to write k, write y, because it's better. It makes more sense if you write it's a sum like that. It depends, but it depends you, like, whatever way make you feel it better, right? Okay, I'm gonna write the sum so that it take less space, and when later when you see I do the operation, it will, you're gonna learn a lot of new things. So all right, so in the basic level, what does it mean? Let's we have to start with some basic level. Okay, it means that, like, for example, if you have d minus r1 square to y equals 0, you can immediately say that y equal to I equal 1 to 2 of a I x, no, I never, I'm not gonna write I, I'm gonna write k equal to 1 of a k x k minus 1. So what does it mean? And then on this times e to power r1 x. So y would become, y is your general solution of I call this 4 of a differential equation 4 will be a1 x to power of 1 minus 1 plus a2 x to 2 minus 1 times er1 x. So y would be a1 r1x plus a2x er1x. Okay, That's what it means. It means that, you know, if you have this system equation, you can use this formula, use this sacred formula. Right here, let me call this 2 star. You can use 2 star. Okay, you can use 2 star to evaluate all of this. Like now you can solve for like d minus r1 equal cube, you know, d minus r1 even power 20. It's really insane, right? You can do it for any cases with any power, and r1 is a number, is any sort of number you want, complex or real, or any numbers work. But now let me actually do something. Okay, I'm gonna prove to you. Okay, using induction. Why 2 star is 2? Why 2 star is true? I'm gonna prove by induction. Okay, so so the first step of induction is that, you know, you're gonna verify. Okay, so you're gonna solve this on your own. I encourage you to do it on your own and verify. To me, the solution is okay equals 0, and then you can verify that the solution is, you know, k equal 1 to 1 a k x k minus 1. I think you can verify for y'all. Then dr minus r1 y square equals 0. You can verify it. You know, I'm gonna leave it for y'all as an exercise, because I think you can solve it like without knowing this formula. You can solve it. Just solve it like the previous example we solved. So should be fine for y'all. Okay. Let's say you verify all this. Okay. So you're gonna say that I'm gonna assume that star is true to n minus 1. Okay, what does it mean? It means that, you know, all this formula to d minus r1 n minus 1 y equals 0. You can use this formula. Okay, you can use this y equal k equal 1 to n minus 1 ak times xk minus 1, and ak is a constant. Okay, ak is a constant. Okay, now you're gonna have to show, you have to demonstrate, okay, from your previous clue. This is from all of this, okay, from all this info. You have to demonstrate. Go on, let me write this. Go on. Demonstrate that d minus r1 derivative n about y equals 0. Then you have y equal summation of k equal 1 to n ak times xk minus 1. Okay, so you have to demonstrate. Let me say this is 3 star. You're gonna demonstrate 3 star using the previous clue. Okay, okay, let's do it, and then, you know, after we are doing it, I think y'all understand better than just me saying it. Okay, now okay, so I'm gonna write I'm gonna manipulate 3 star a little bit. Oh no, actually no. I'm gonna manipulate this expression a little bit. Okay, d minus r1 to the power n y. I'm gonna write like this: d minus r1 n minus 1 d minus r1 y. You guys agree? Okay. And then I'm gonna set this equal to z, classic way, very classic. I'm gonna set this equal to z. Okay, so it become d minus r1 n minus 1 c. Okay, so what do we have? We have d minus r1 n y equals 0. Okay, so what do we have? We will have, because this is outgone, this is 3 star. Okay, so we have d minus r1 to the power n minus 1 z equals 0. You guys understand, because we just showed that they are similar. So this, if a equal b, a equals 0, b equals 0. So right here, I just show you, I just demonstrate to you similar. Okay, so now I'm going to use the past knowledge. Now, if I can use this formula, right? You see what I'm saying? So d minus r1 to the power n minus 1 of something equals 0. It can be anything. Okay, so I'm going to use this formula right here. You see what I'm saying? But I'm going to replace y with z. Okay, so d minus r1 n minus 1 z equals 0. So z equal to the summation. Okay, so I will have this. I'm going to have z equal summation k equal 1 to n minus 1 a k x to the power k minus 1. Okay, now I'm gonna solve for y. Okay, what do we have? We say in previously d minus r1 y equals z, right? So what do we have? We have d minus r1 y equal summation of k equal 1 to n minus 1 a k x k minus 1. Okay, you with me? You with me? Okay, now we use the, if you watch the previous video, I'm gonna use the legendary formula. Okay, applied to blue right here. Okay, and what's that legendary formula, ladies and gentlemen? All right, this is this one. You remember? Equal to e-ax d1 e-ax. Yes, this one right here in red. All right, and this is true for n. So so it to how 1 1 2 2 3 3. You see what I'm saying? It's true for anything. Anyway, so I'm gonna transform this into e to power r1x d of negative a r1x y equal to summation n minus 1 k equal 1 a k x k minus 1. Okay, now oh my god, guys, I just realized something. Oh god, you know what I have been doing wrong? I'm so sorry for this inconvenience. So I missed the e to power r1. So okay, look at 2 star again. You see how it times e to power r1x? I miss it. I'm so sorry. So this has to be r1x. Let's add all of them, okay, to our term. Equal to e to power r1x. I'm so sorry. This times e to power r1x. I'm gonna make it right this time. Yeah, you know, that's why sometimes I always miss something. You know, it's so weird. E to power r1x times e to power r1x. Okay, I miss it. That's why, because it's supposed to cancel out, or we cannot do it, you know, or yeah. Okay, you see what I'm saying? I just write the statement wrong. So this is the solution. This is the true solution. Okay, you have to times e to power r1x too. So I forget it from the beginning, from 2 star right here, the model equation, and then I just forget to rewrite it in some way. Okay, I'm sorry to confuse you guys. Let it. You can look at the papers. The solution in the paper, they have e to power r1x. So cannot miss that. Okay. All right. And then, you know, I'm gonna cancel both sides, right? Because they're equal. Yeah, that's why I feel I missed something, because I remember I worked this on my piece of paper before, and I remember, oh, e to the power r1x have to cancel out, and I was like, dude, you literally forget it. Go back and fix it. So yeah. Alright, thanks God it cancel out. Let's go on. So I'm gonna rewrite this, but I'm gonna write in normal form. It would be d over dx e power r negative r1x y equal summation k equal 1 n minus 1 ak xk minus 1. And remember, guys, ak is a constant. Okay. Alright, so I'm gonna integrate both sides, and sorry guys, earthquake. I'm gonna integrate both sides, so you got e to the power negative r1x times y equal to integral of the summation of k equal 1 to n minus 1 ak x k minus 1. Alright. This is when meme come alive. I'm gonna do something, which a poor mathematician would jump right into my face, would jump the chair and say, "Why, Justin? Why would you do that?" To honor the poor mathematician, or someone interested in this issue, I'm so sorry. I'm gonna assume it to be happen. I'm sorry. I'm not gonna prove it. Probably I don't know how to prove it, or probably I just want it to happen. Like, I'm not gonna knock on your doors this time. I'm just gonna come in your room because I want things to happen. And I know it's true, but I just don't want to show it in detail. Okay, so what I'm gonna do is I'm gonna exchange. This is like a meme, you talk to hardcore math people, they would say like, why would you exchange the boundary, the operator, the operation? Why would you do that? So what I'm gonna do is I'm gonna exchange the integral sign and the summation. So what do I mean? It means that I'm doing something like very godly, but also it's gonna raise a lot of question. Okay, so I'm gonna be like summation of k equal 1 to n minus 1 integral of ak xk minus 1. Okay. Oh, I forgot dx. So should have dx. No, not this one. Dx. Yeah. Like this. Yeah, that's what I did. All right, does it make sense? The reason I think probably I can do this, I think, is because ak xk minus 1 summation is continuous, I guess, because it's polynomial. So yeah, that's probably why. Okay, with that being said, we're gonna proceed. It's fine. I mean, it's a really minor thing, if you just accept it, like right now, like it's a really minor thing. It doesn't really matter. So the most important thing is you're gonna see what we get from this. So it's the summation, and k 1 to n minus 1. What's this integral? This integral is ak times x to the power of k over k, right? And then don't forget the most important thing, plus c. Okay, so all right, and then what I'm gonna write e to the r1 x times y equal to summation of n minus 1 k equal 1 ak over k times xk plus c. Okay, so I'm gonna time r1x both sides, so y equal to c plus summation of k equal 1 minus 1 ak over k xk times e to power r1x. Okay, now I'm gonna rewrite a little bit so it's look like more similar to the equation. So okay, so this is c plus summation was this is a n a1 over 1 plus times x power 1 plus a2 over 2 times x power 2 plus yada 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 plus an to the power of wait. Yeah, an to the power over n. Wait, no. I'm so sorry. Okay, an minus 1 2 over n minus 1 times x to the power n minus 1 times e to the power r1x. Okay, this is just, I just expand the sum a little bit. Okay, I'm just expanding the sum. So literally, this thing right here corresponding to the sum. Okay, guys, you guys, does it make sense? Okay, but now let me write. You see, Justin, it doesn't look like the solution they're giving. So let me rewrite a little bit. Okay, I'm gonna rewrite. You remember that? Notice that C a1 over 1, a2 over 2, yada yada, a n minus 1 over n minus 1 is constant, right? So it's constant. I can replace whatever I want as long as I can replace it with any character in the word I want. Any character, any alphabet character I want. Because it's only denotes a constant, okay? So I'm going to rewrite this a little bit. So y, okay? I'm going to replace it a little bit. Y equal to a1, okay? Plus a2 x1, x to the power 1, plus a3 x squared plus all the way to a n x n minus 1 e to the power r1x. And ladies and gentlemen, this is our solution. So someone asked you, did I just replace C with a1 over 1 with a2 over 2, a3, you know, and a n minus 1 over n minus 1 with an. Because because you have to understand they're constant. I can write in whatever form I want, okay? And this is the former solution right here for you. So the key takeaway from this is induction is important. We can exchange, and that's the first thing. The second thing is we can exchange the integral and summation aside because the equation is continuous. Then and then you just review, now you can use this very, very powerful tool to solve any differential equation if you can factor it. Like for example, if your professor asks you to solve this one, okay, let me give you an example. Okay, so how you solve this differential equation? Okay, I know a lot of you are screaming right now. So okay, so how you solve this differential equation? The 3y, right, minus 3d squared y plus 3dy minus 1y equals 0, right? So you factor it, d cubed minus 3d squared plus 3d minus 1 y equals 0, okay? So what do we have? We have this one right here. This is cubic expansion. It would be d minus 1 cubed y equals 0. Okay, so what do you have? You can immediately say that y is the summation of I equal 1 to and in this case is 3, so 2, okay, because it's 3 minus 1, okay, this 3 minus 1, ak times xk minus 1, and don't forget guys, times e to the power of 1x. Where's the 1 come from? Come from here. Okay. Okay. Yeah. So if they ask you to write in like, standard form, you say fine. I don't want. If you want me not to, if you don't like the summation form, I can write a standard form for you. It will be a1 x to the power of 1 minus 1 is 0. X to the power of 0 is 1. 1 times a1 is a1 right here, plus a2, right, times x to the power of 2 minus 1 is x. Okay. Then all of this, okay? Times e1x. Let me make sure. I have to make sure. Yeah. Because it have to be all the way to n minus one. Okay. Good. All right. Oh shoot. I suck, guys. I'm sorry, guys. Yeah, let me do it gradually. So okay, a1 x power 1 minus 1 plus a2 x power 2 minus 1 a1x. Okay. It's 1 2. Okay, so what is that? I just want to redo it to make sure. A1 plus a2x ex. Okay, so what is one? Wait, it's so weird. It's cube, right? I hope I didn't do anything wrong again. I don't know why I always run into trouble. Let me see the phone. Check the back 3 star. Yeah, it should be yeah, that's what I meant. Like, okay. Yeah, it have to have x. Oh no, it's not. Okay. I know where I got wrong. I'm so sorry, guys. This is 3. That's so funny. This is 3. Okay, this is 3. It's not 3 minus 1. Okay. And where's that 3 come from? 3 is from here. I'm so sorry. That's why. That's probably the reason why. Okay, let me adjust this for y'all. A 3 times x for 3 minus 1. I have to practice how to make perfect YouTube video because I keep running into my own mistake all the time, you know. Ex. Okay, so what is y? Y is a1 ex plus a2 x ex plus a3 x squared ex. Okay, and ladies and gentlemen, this is our solution. Right? Yeah, that's it. Like, you know, just be careful with the summation sign. You know, it's very simple when you apply it, and then you can solve like similar problem like this. Okay, it's really interesting. I hope you guys learned something new today. Sincerely. And yeah, let me do one more characteristic. Okay, this video is gonna be a little bit long, and I apologize for that. I sincerely do apologize for this. Actually, I didn't intend to make it long. I can split the video. Yeah, let me actually go ahead and split the video.